Okay folks, welcome back. This is going to be a continuation of my last video where I showed you how a computer turns on. And we're going to go over reasons why it won't turn on, only relating to the 3.3 linear voltage that goes to your Super I/O chip from a power chip and to your button, to your on-off button. All right, so let's take a look at our board here. And we can tell that there's a problem with this Super I/O chip. Not only does it have a big burn mark, but there's also a hole, a couple holes right there. But let's pretend that we didn't see that, all right? So the first thing in diagnosing a computer is we check our main power rail, and as you can see by looking at the voltmeter, I've got 19 volts going. If there was a short on the main power rail, there would not be 19 volts there. So the main power rail is not shorted. And you can see it has a little bit of amp draw, about 4 milliamps. We really want about 10 to 20. So we can already see, without looking at the board, that there's a problem. So we know we've got 19. So let's first let's check around, see if we've got 19 at our CPU. So I'm going to turn this over. Let's check around for 19 volts to verify that our main power rail is up and running. So I'm going to stick one on ground, stick a lead on ground, and let's see, where do we have 19? Where do we have 19? Well, there's 18.95, so we've got a little bit of a voltage drop. So the main power rail is up. All right, let's go back to our Super I/O. Some people do call it an EC chip. Some people call it a Super I/O. Okay, now we need to look for the 3.3 volts somewhere around the Super I/O chip. So we're going to stick one end, the black one, on ground. That's any metal pretty much on the board. And we're going to check these capacitors. There's nothing there, nothing there, nothing there. Here, nothing, nothing. There's nothing there, nothing there, 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 nothing there, nothing there, or on these resistors. And we can even drag this and we won't see 3.3 volts on this chip. Okay? All right. So our 3.3 is missing. It could be missing for multiple reasons. One reason, the chip that supplies the power could either be broken or shorted. The traces between the power chip and the Super I/O could be broken. Or one or the other, or a capacitor around one or the other, could be shorted. So that's what we're going to test for next. Do we have a short? So I'm going to go to ohms mode, and I'm going to check these capacitors around the I/O, Super I/O, and see if I have a short by placing it on both sides. There, I've got just 4 ohms. Okay. Okay. Let's go around here. Okay, that's a 2.8 ohm short. Okay, they're not 0 ohm shorts to ground, but that is too low. They should actually be measuring open. Okay, shorted. So essentially all of our capacitors around our CPU are showing a short. And without this burn mark here, let's assume we can't see it. Could be one of those capacitors. So what we're going to do is we're going to inject voltage at one of the shorted capacitors. All right, now the way I'm going to do that is I'm going to turn off my power supply, and I'm going to go with my injection. Now, we normally inject voltage at the lowest voltage that is on that rail. Okay, so when we inject voltage on the main power rail, we inject just 1 volt because the CPU, the GPU, the PCH, they all run on that lower voltage. But this is a 3.3 volt rail, so I'm going to change my voltage up to 3.3. Whoops. Okay, and notice I have my amps limited to just 2 amps. Okay, and now we can go ahead and inject our voltage. Well, I guess first I have to turn it on. Okay, so we can inject voltage pretty much on any one of these caps. So I'm going to go right here, and okay, did you see what happened to my here, I'm going to move this so you can see. If you see what happens to my bench power supply when I touch it, the voltage drops to nearly nothing, and it automatically goes to the maximum amps, and I have the amps limited. So let's take a look at it on my infrared camera. Let's see where that heat is. Okay, you hear that alarm, and you can see that there's a great big and essentially great big red spot. The maximum temperature for this infrared camera is 200 C. Now you can see the shape of my Super I/O there, and it is getting mad hot, absolutely mad hot. It's still pretty bad. So let's do that one more time. Okay, I think my camera has got, or at least the screen capture has an alarm on it. Okay, you can see that that is the Super I/O getting mad hot. Now there could be other problems, but the Super I/O is shorted. All right, I'm going to turn off my screen capture. So what you do at this point is you need to remove your Super I/O. Let me move over my lighting, a little better lighting on here. All right, now this is a little advanced for my channel. On my channel, I like to kind of show you the basics. All right, but I'm sure, and I've seen some of your guys' profiles, you're watching other folks. All right, when you're a beginner, taking off the Super I/O is no big deal. It's putting it back on. All right, and I'm going to do that using the simplest way, the easiest way. All right, so I've got my hot air, and I've got a little bit bigger tip on it, as you can see here, a little bigger tip because I want to cover more area, and I'm going 480 at max temperature. Now we will need to keep an eye on the capacitors nearby, you know, around here, but I'm pretty sure we can keep track of those and none of them will blow away, and if they do, we'll just put them right back. Okay, and I'm going to grab my tweezers, Now I'm going to come in, and guys, remember when you're soldering, especially when you're desoldering a large component like this, the whole board needs to be heated up. So I'm just making circles around the Super I/O, and I'm not real close. I'm not as close as I could be. And that's to kind of slowly heat it up. And then I'll come closer, and I'm going to emphasize not necessarily heating up the center of the I/O, Super I/O, but emphasizing pointing the heat on the pins. Okay? Now I've seen some people do this with a very small nozzle, at least put it back on with a small nozzle. And that's actually how I do it. But I'm going to show you guys the easy way. And remember, those guys that we watch on YouTube, they're in business. And they got to get things done fast. Well, if you're a hobbyist or a beginner, there is no reason to rush things. Might as well get things done right the first time. Okay, we're getting close in here. I'm just going to start testing out, see if this Super I/O is moving at all. Okay, no. Now, remember, the factory solder is very high melting solder. They started doing that in the 90s, started taking lead out. And so that's why it takes a bit. Okay. Checking. Okay, we're starting to move. Okay. Keeping the heat on, always keep the heat on whatever you're removing until you lift it off. Okay, otherwise it'll just get stuck. So there that is. All right. Now, what I'm going to do next is I'm going to add some lower melting solder, not low melt solder, but lower temperature melting solder to my pads here so that putting it on will be easier. I'm going to be using a conal tip just to show you that you can use a conal tip for this. All right. There are other people that really feel that you need either a more like a knife blade or a chisel or a bent conal, but usually this is what you get when you buy a soldering iron, and this can be done with just a regular soldering iron. I am going to put some flux down. As you can see, there's some factory flux that has come up with that, and boy, I don't like those hairs. And I'm just going to lay some flux down. The area is still hot. Okay. Now guys, some of you probably have experienced some frustration with micro soldering. The key is having a soldering iron that consistently hold 400 degrees Celsius, okay? As long as it can consistently hold at least that. And then solder that melts at around 200 C. This particular solder melts at 193 degrees Celsius. You have those two things, and micro soldering will be a lot easier for you. So I'm going to come down here, and I'm just going to approach my There we go. And I'm just adding, through drag soldering, adding some lower melt solder to my pads. Okay? And we can worry about bridging later. I'm touching each pad, okay? And each pad does have a good amount of flux on it. Okay? Now we'll take care of any bridging. See a little bridging there. Just do a little cleanup, a little bridging there. Some little balls. And what makes this possible is I've got flux, I have a soldering iron that's at 400 degrees. It's actually at 402 degrees Celsius. See the bridging there? Easily taken care of with the heat of the soldering iron and flux and that low melting solder temperature. And things go a lot easier. And you see how shiny that is? And that's pretty much the secret to micro soldering. Here we got a little bit of bridging was going on right there. A little bit of bridging right there. Okay, and a little bit right down here. You gotta take care of those bridges. A little bit right there. Okay, now what we do first before we put on another chip, which I happen to have, is we need to check, is our short gone? So I'm going to go ahead and go back to ohms mode, ohms beep. You see a lot of people use diode mode, which actually that is kind of a better mode to be in, but a lot of you, it's on the same switch as it's on the same position as the diode mode, the low ohms beep. So let's see. No short. There's no short on that cap. There's no short there. No short there. Where else can we look? Above here. Okay, so let's take a look. Nope. Okay, you're going to want your microscope zoomed out to where you can see the entire area where you're going to be putting your new EC or Super IO, and that's so you can line it up correctly. And we're going to use a soldering iron instead of a hot air gun, as many of you probably do see other YouTubers doing. And they do that for a couple reasons. One, they've done it an awful lot, and they are a business, so they're in a lot more hurry than either a beginner or a hobbyist is. So the easiest way to get this done, and done correctly the first time, is with a soldering iron instead of hot air. So I'm just going to go ahead and line this up, and I'm going to add some flux. Doesn't have to be a whole lot. All we're going to do is start off by tacking a couple corners. Oh, I need to straighten that back up. It moved on me. So you want to line up your corners. You need to be able to see at least 3 corners. I'm going to get awfully close to my finger here. Here we go. Here. And I can pretty much, if I get down to this corner, I can let go. Okay, and this is drag soldering. Okay, I can let go. I'm going to put a little more flux on the other sides. And since we're not in a hurry, we can just do this right from the first take. Now I am going to add a little more solder to my soldering iron. And it's okay if we get a little bridging, we'll fix that later. And my soldering iron is at 402 degrees. Let's get a little more solder on here. And a little more on this side. Okay. So we are now soldered in place, and all we have to worry about now is bridging. Okay, folks, we've removed our Super I/O chip, and the short is gone. All we need to do is put on a good Super I/O chip, and then our board will start. Hey, I'll see you guys next time. Thank you.